Welcome to C++tutor.com. This is the production of C++tutor.com, YouTube channel Learnorama, and the Facebook page Awesome C Programming Tutorials in High Def. In this tutorial, we are going to talk about the disadvantages of using an array. You know, we have been studying arrays before. We have, there are many tutorials I made on arrays, and I love arrays simply because they are very easy to create arrays, to store data in arrays, to access the data in arrays, and everything. So it's always a favorite of any programmer. But unfortunately, there are some hidden disadvantages of using an array, which we don't realize until somebody tells us. So what are those? So let's take a look at an array. We all know that an array is actually an array is essentially a big chunk in memory where you store a list of elements. So if you have a list of integers, for example, you allocate a big chunk of memory, and that's where you store your integers. And it really depends upon which programming language you are using. There are different, there always are arrays in every programming language. So, but the way to declare an array could be different. In C, for example, we have seen this before. If you are trying to allocate and declare an array of integers, you declare it like this. And in here, you have to specify how many elements your array is going to have. So for example, 100 elements. So now if you declare it this way, in general, the size of this array is the number of elements here times the number of bytes required to store each element, which in this case each element is integer. So most of the time in a 32-bit machine, it's gonna be 4 bytes here, and 100 elements, which will take up 400 bytes. Now this is a very simple example. In most of the programs, the real programs, the professional programs that you are going to be writing, you are not going to be creating arrays of integers. I mean, of course you will be creating arrays of integers, but not necessarily. A lot of times each element itself, this little box here, this could be a complicated structure. It could be as an struct. You define a struct, my struct, and then you define a lot of other things in here. Integer, this. There could be an array of integers inside it. Okay, and there could be strings inside it. So character, name of 100, and so on. So the size of this structure itself could be, I don't know, like 1 kilobytes or maybe more. And then you might end up in storing like 1,000 of those, right? I don't know, maybe like you are trying to store a structure, and this structure for every person, every single student in a school, and there could be 1,000 students. So that brings your total to 1 megabyte right there. And then this is just one array, and there could be like many other arrays for different things. So your program size could grow real fast. The thing is that you might allocate 1,000 elements here, but you may not use them. But you have no choice. I mean, what you are doing is you are trying to allocate the maximum number possible. What you are saying is that, okay, in this school, the number of students is not going to go above 1,000, and that's why you are allocating 1,000 elements in this array. If this structure is holding the information about a student, one single student, you want 1,000 of those structures. So each one of these boxes actually represents a student, essentially. So what you have, if you are trying to store it as an array, you have to like guess that what would be the maximum number of elements. and you have to give some margin also. Okay, so if you expect that your students is not number of students is not going to go above 800, you want to create an array of 1000. Okay, and currently your number of students could be just 500, right? You are expecting that in the future it might go all the way to 800 or 900 or something, so you end up in allocating 1000. So currently your count is only 500, so out of those 1000 elements in this array, you are just using only maybe like 500 or something, right? So you are wasting most of the memory, and you have no choice. You cannot allocate a smaller size of array because your software is going to break if you start, if your number of students exceeds the maximum that you estimated, or the maximum size of this array. So you have to estimate the maximum size of every array in your program so that you never exceed out of it, because otherwise you are going to run into issues, into bugs in your program that you will not even be able to debug. So what's the problem here? The problem is that arrays are static in that they cannot change their size as far as number of elements is concerned in at runtime while your program is running. So that's where the major problem about arrays. Arrays are fixed size, predetermined size. Okay, because of this you have to because of this you actually have to estimate what is the maximum number of elements, and you may not even there may be some applications that you may not even be able to do, and you have to be optimistic so that you allocate more elements than you actually need, so that you don't run out of the memory, or you don't overflow out of the array when you are accessing, or when your program is running. Because in C at least there are no checks. So if you declare an integer array like this, and then you are accessing the elements, for example, if you have to access element number 1, this is how you access the element number 1, right? Array of 1. If you have to access element number 29, that's how you do it. But if you have a generic index I, then depending upon the value of I, you will be accessing different elements in this array, right? If I is equal to 29, you will be accessing element number 29. But if somehow your I changed to 110, then you will be accessing 110th element of this array, which actually does not exist, but you are not going to get any kind of error in your program. When it's running, you are not going to get any kind of error. What you will end up in accessing is the memory location which corresponds to the 110th element. And that's bad, because your original allocation was up to here, and this memory belongs to somebody else. It may belong to the same program, and may belong to your program, but it is actually holding some other variable. And now you will be changing, modifying, and using the value of that variable that's stored here without knowing it. And that's going to result in weird behavior in your program. So these are the issues with using arrays. That they are statically allocated, they are fixed size, and you have to estimate in advance. You end up in wasting a lot of memory when you are dealing with array, because you have to estimate more than you are actually needing. You have to estimate more than what you currently need, and you have to estimate more than what you are going to expect in the future for this array to grow, so that you never ever run out of overflow this array. And there are other issues with arrays. For example, suppose if in this array you always want to keep the list sorted, right? It's an array of integer, so 9, the value stored here is 9, 23, 25, 64, 68, and so on to 129, for example. Okay, so you have sorted list here. You always want to keep this list sorted. Now if a new integer comes in, say 10, so what do you have to do? You still want to keep this list sorted. You are not going to be able to insert it at the end. Well, suppose there were only 5 elements used. The other ones are not even used. So these are all empty. So they have garbage. So you will have to have some count somewhere that what is currently, how many elements are used here. So this count is going to be 5. Okay, it's going to keep track of how many elements out of this array are actually have the valid values. Everything else, they will always have some value, but it's all garbage. So you will have to keep track of that. So suppose there are only 5 integers at this point, then the total number of elements are 100. Okay, now you have to insert 10 in here, but you want to keep your list sorted or your array sorted. So where do you want to store 10? Are you going to store 10 here, which is the next available space? If you store 10 here, it's going to make this array unsorted. It's not sorted anymore. So where is the right place for this 10 to go? This number to go is here in between 9 and 23, but there is no element here. So what you'll have to do is to move all these elements one block up, one element up, so that you have an empty space here, and then you can store this 10 here. Now in this example there are only 5 elements, so it's not too difficult. I mean, it's not going to take too long to do that. If you have 10,000 elements in here and you have to insert something in the first location in an array, you have to move all those 10,000 elements one element up, and that can take quite some time. That can slow down your program, so it's very inefficient. So if your application is such that you will be ending up in storing elements in the middle of this array, then array is not a good choice. And what's the good choice? We call it linked list. Linked list takes care of all these disadvantages of array. Linked list takes care of the fact that array is a fixed size data structure. Linked list, every element is individually allocated, separately allocated in memory, and then they are linked together. So you only use up most of the memory that you use up in linked list is the memory that you actually need. You don't waste any memory. Well, you do end up in wasting a little bit of memory because you want to do some stuff to basically relate those memory locations together to form a list. We are going to see this in the next tutorials. But it's relatively speaking, it's a very small percentage of memory that you end up in wasting. Most of the memory is used to store data, and you end up in allocating only the memory when you actually have some data to store. Okay, and the other thing is that it's very easy to insert something in the middle of a linked list or at the front of a linked list. It's extremely easy. It's very fast. You don't have to move the elements around and stuff. So linked list takes care of all the disadvantages of an array, and we are going to see what a linked list is in the subsequent tutorials. Thank you very much for watching. As usual, if you like this tutorial, please don't forget to give a thumbs up, and don't forget to visit the ctutor.com website.